The world is changing and the technology is evolving. But have you ever wondered how safe the world is anymore for us humans? The environment is being constantly contaminated with various pollutants and contagious elements. It is people, just like you and me, who have to deal with all these biological, nuclear, fire, chemical, and electrical hazards. It has been recorded that occupational hazards take 6,300 lives a day worldwide. One of the most recent examples include the corona pandemic, where the medical staff and the cleaning personnel having to deal with viral contamination firsthand. The solution to this is reducing human intervention with contagious environments. And that's where robots come into play. The introduction of robots to perform high-risk and repetitive tasks have cut down the physical and psychological hazards by a major scale. The highest credit here goes to manipulator robots, which are also known as fixed-based robots. But the same cannot be said with regard to mobile robots, since they have not been able to cater to the industrial and commercial requirements in hazard mitigation as expected. The reasons for this could be identified as high cost in design and manufacturing, complex design requirements where you have to change the robot design based on the task it's performing, and only being able to travel in limited environments or terrains. But what if I told you that there was a mobile robot that was cost effective and highly customizable? Introducing ArcPed, a task-oriented, autonomous legged mobile robot with a novel design. The Eccentric semicircular robot leg acts as a hybrid leg wheel model, adding the best of both wheeled and legged robot worlds to the design. With this innovative design approach, the robot is capable of walking on any rough surface, which could include flat, tiled or wood surfaces, granular roads, grass, and even on sand or mud. ArcPed has its own gait pattern generator, which allows him to identify the most optimum gait pattern for the surface and part type. This allows ArcPed to travel up and down stairs and other unstructured environments, which a typical wheeled robot is not capable of. ArcPed comprises of a navigation system that gains feedback from a LiDAR sensor, and as an optional feature, it has a vision-based object recognition and navigation system. Apart from that, ArcPed uses a SLAM algorithm for localization and mapping. ArcPed is fully backed with comprehensive engineering design analysis and simulation data. A functioning prototype 2 is currently available, which solidifies the hardware feasibility of the robot. Further testing is being carried out on the robot using the simulation and the prototype to identify optimum technical specifications. ArcPed could cater to many health, safety, defense, surveillance, and monitoring requirements in local and international commercial organizations, including factories, hospitals, hotels, car parks, and agricultural sites. One of the key features of ArcPed is that it is highly customizable and the robot acts as a self-navigating all-terrain platform. ArcPed could be customized and used for remote surveillance and monitoring, UVC disinfectioning and spray cleaning, mine detection and for agricultural use, and with its 8 kg excess payload capacity, it could be used to move objects from place to place. ArcPed comes with a user-friendly mobile application which could be used to track the location, power level, and the task progress. The app could be used to control ArcPed as well. The user has to assign ArcPed the task and the path, and the robot does just that. Along with all these, the robot is highly cost effective. The cost estimation of the robot roughly sums up to just $600, which is close to the price of an average vacuum cleaner robot. A high-end robot with off-road mobility would cost much more than this. As you could see, ArcPed is a platform trying to revolutionize hazard mitigation using mobile robotics.